I've been asked to make a short video here by a few colleagues. So this video is basically meant for them, but I'm posting it as public just because it's interesting. Well, at least I think it's interesting. Now, this is to do with the key pair password system. This is a method of storing user authentication by means of a public-private key pair, and I'll go through the basics of what's going on between the server and client. And this is essentially this is not really for web-based stuff, it's for application level stuff, but you know, there's no real need to do it with web-based things. So first of all, we have obviously the client and the server. Now, registration, when the client first signs up, should really be done client side. Yeah, so some of the processes should be done here on the client side. You can do it server side if you've got like a web registration system. There's no problem doing it server side, but you know, for maximum security it should be done on the client. So for this demonstration I will show these processes being performed on the client, but some of them can be done on the server. So first of all, we have the client who will obviously want to sign up and register an account with the server. So the first thing they do is they generate a username, and this username is sent to the server. The server checks the username, and assuming that it's not already taken, it will generate a random salt, and this is then sent back to the client. The client is then asked to choose a password, which they then type in. And this password, you should have something on the client to, you know, check that it's a decent password and not just 1234. If the password is suitable, then the password and the salt are combined together, and the username, if you like, that's optional, but basically the password and the salt are put together. And using a process, and this process can be anything you like, yeah, that's completely up to you how you implement this. You generate a private key. And here I've called this process M, but of course, you know, that's up to you how you do that. Once you've derived your private key from the password and the salt, and optionally the username if you want, you can go ahead and generate a public key from that. And then that public key is sent back to the server. The server then saves the salt and the public key and the username in the database. And that completes the registration. Now, of course, if you're doing a web-based registration, a lot of this process can actually be done on the server. You've just got to make sure that when you calculate the private key that you destroy it. Yeah, you do not store that private key. You wipe it from memory, do whatever you need, but yeah, that is the essential part. That needs to be gotten rid of if you're doing this on the server. But for maximum security, do everything like this on the client. Okay, so now we're registered, let's do the login. Okay, so your client has been and your customer has been registered fine, and now they want to log into the server. So the first thing the client will do is ask them for their username and password. Then the username only is sent to the server. The server then looks in the database and retrieves the public key and the salt for that particular user. The server then sends the salt back to the client. Using the password and the salt, and optionally the username if that's what you've selected to do, the client uses method M to generate a private key. Now the server has its own public and private key. And these are unchanging, they're the same for every connection. And the client has this public key hard coded into it. Now, this isn't 100% required, but doing it this way makes a man in the middle attack a little bit more difficult to accomplish. So, the first thing that the client does, it grabs the server's public key from wherever it stores it. And the server will grab its private key from wherever it stores it. Now I'm just going to move this around a little. I'm going to put the salt up here. So to go through the process again, client types in the username and password. The username is sent to the server. The server then goes into its database and it pulls out the salt, the client's public key, and its own private key. The salt is sent back to the client, and the client uses the salt and the password and or the username through process M to derive the client's private key. It grabs the server's public key, which is hard coded into it. Yep. So now both sides have each other's public key and have their own private keys. So they now have enough data to generate an encryption key. Now the encryption keys should match for both sides, a standard Diffie Hellman type thing. So both the server and client now can perform a challenge. And if the challenge succeeds, then the user is authenticated. Of course, the type of challenge that you use is completely up to you, and you can also, of course, use the encryption key in any further communication done between the server and client if you so desire. Okay, so that's the basis of it. If you want to, let me know and I will show you an actual working example of this, go through the maths involved. But if you're familiar with the way cryptography and essentially basic Diffie-Hellman key exchanging, then that should be enough information for you. Alright, thanks. Bye.